All right, so we are going to look at quadratic equations here, which are parabolas when we graph. And our first couple are just looking at some graphs. I'm going to go ahead and talk about things. Hopefully you watched the other video because there are pieces you need in there. When you have a parabola, very important thing to be able to pick off is the vertex. And if we are in what's called standard form, and standard form looks like this. Sorry, that should be an X. So A times x minus h squared plus k. So this is a minus and this is a plus. And you can pick your vertex off if you were in this form. The vertex is hk. Now, if we're not in this form, later on in this section, we'll use a formula for the vertex. It's too much work using complete the square to go back to this form. So we use a formula instead for the vertex. To graph these in general, what you need to graph a parabola is know that it's symmetric and know the vertex. You have a line, a vertical line through the x-coordinate, so h, of the vertex, which is called the axis of symmetry. So it will be x equals whatever this is. And the graph will flip across that. So if you know the vertex, you know which way it opens, and you know one point, you can draw the graph. This A, if the A is positive, it opens up. If the A is negative, it opens down. So A greater than 0, it opens up. A less than 0, it opens down. So that is helpful information which you will want to know. This, I think you could look at it as transformations, or you can look at it with the vertex and a point. You could look at it either way. It is a variation. All of these are variations of y equals x squared, or f of x equals x squared. Right, so we'll do one with a transformation, and then the others we're going to do with a vertex, I think, and 1 point. Okay. All right, so this graph, remember your standard graph, your vertex is at 0, 0. It opens up. And you can have a point or two. And these just move it. So we'll do one with a transformation, and then I'm just going to go to the vertex method. All right. So let's draw our standard one. We're using a 5 here, so I better get 6. All right, so our standard one is 0, 0, and then it's 1. 1 squared is 1, 1, 1. 2 squared is 4, 1, 2, 3, 4. And it flips across. This is your axis of symmetry, that y-axis there, x equals 0. All right, so this is our standard graph, and we'll do one transformation. So we'll do the first one with the transformation. If we're going to do f of x equals x minus 5 squared minus 3. All right. Remember, if something's inside, that's a horizontal shift, and it will go the opposite. So if it's a minus 5, it's going to go to the right 5. And this is a vertical movement. It's going to go down 3, right, from the standard one. And I'm going to have to get a little bit more down to get my tool. All right, remember when you use this parabola tool that you need 2 points and you have to do the vertex first. So if I'm going to shift this vertex to the right 5, 1, 2, 3, 4, 5, and down 3. 1, 2, 3. I'm going to be right here. And I need to move one other point the same. So this one I'll move to the right 5 and down to the right 5 and down 3, 1. That one must not be down 3. 0, 0. 1, 2, 3, 4, 5. Down 1, 2. It should be more. All right, that one will be the vertex. So that one is the first one I'm going to plot on there. And the other one I'm going to move this 1, 1. So I'm going to the right 5. So it's going to land, it's at 1, it's going to go to 6. And then it's going to go down 3, so it will go to -2. So this is 6, -2, and this is 5, -3. All right, and I'll graph those on here. It's not going to let me check until I get all 4 of them on. All right, so 5, -3, and 6, -2. All right, and that's the first one, and that is by a transformation. All right, I'm going to do the others with the vertex and knowing how they open, and then we'll need to get 1 point. All right, so hopefully you guys have this part all down. So g of x will be x plus 5 squared plus 3. All right, so my vertex here, remember your form is x minus h squared plus k, right? So my vertex is going to be, because this is plus and my form is minus, my vertex will be -5 and 3. Right? I need one more point. An easy point to get is the y-intercept, right? Because you plug 0 into x, right? So one more point. So if we do g of 0 is 0 plus 5 squared plus 3, and 5 squared is 25, and this is going to be too big. So I need to get this smaller. So I'm going to pick a different value for this one. To make this smaller, I want this to go down, so I need to put a negative value in there. So if I put a -4, so -4 plus 5 squared plus 3. And this won't be the y-intercept. This will just be a point. So you just want a point that makes it true. All right. So this will be 1 squared is 1 plus 3 is 4. Right. So -4, 4 gives my extra point. Right. And my graph. So I'll do my vertex. So start at 0, 0. Whoops, you gotta click the tool first. Right, I want -5, 3. And -4, 4. Right, and we can look and see if this one did move correctly. So, because we have the graph there, it would have moved to the left 5 and up 3. Check it from the vertex. So to the left 5, up 3. There you go. Very good. Very good. All right. Next one. So we're going to have 4 on one page. So you should be really good at this after one problem. All of these are opening up because in front of each one, it's a positive 1. So they're all going to open up. All right, so my vertex from this, it is in the minus form, so it's going to be 5, 3. Right, and to pick, we'll just pick a random point here because putting 0 in is going to make it too far to the negative. So if we put in, say, a 4, right? 4 minus 5 is a negative 1 squared plus 3. So this would be 1 plus 3 is 4. So 4, 4 is going to be a random point on this. So we're going to have 5, 3 for the vertex. So 5, 3, click, and then 4, 4. So there's that parabola. We can check and see about the transformations. All right, this is minus 5. Remember, horizontal shift, and it goes the opposite. So it should move 5 to the right and up 3 from 0, 0. 5 to the right, up 3. Yes, it did. So we're good. And one more to go on this picture. We can write it on this same one, I think. So this is j of x equals x plus 5 squared minus 3. Right, this is plus, so watch out. So your vertex is going to be minus 5 minus 3. And a random point. All right, we still want this to not get too big. So let's put a negative 4. In. Right, so negative 4 plus 5 is a positive 1. So 1 minus 3 gives us a negative 2. So negative 4, negative 2 gives us a point. We'll do the vertex first, so do our tool. Negative 5, negative 3, and then negative 4, negative 2. Right, and if we're looking at transformations, this was plus inside with the x. That means it needs to go to the left 5. It did, and down 3. There we go. So hopefully our graphs are good. There we go. So next question. I don't know if we'll graph all of this one or not. Number 2. Let's just do one of them. Let's do just J. And what I wanted you to see is negative in the front. These two are going to flip upside down. The others would not. Okay. So we'll just do J of x is negative x squared plus 8. I also wanted you to see this is the same form, a times x minus h squared plus k. Your a is negative, but if you just have this piece and you don't have a piece subtracted, that h has to be 0, right, to just get your variable. So our vertex off of this is going to be 0, 8. And this one is going to open down. That's just helpful for later. Let's see, our scale is 10. And so plugging in 0 is not going to help us. We're getting a random point. We'll just plug in a 1, right? So if we do 1, now the negative is not going to the power because you don't have parentheses up here. The 1 is going to the power. 1 squared is 1. So we have negative 1 plus 8. This will give us 7. What we plugged in was 1. So 1, 7 will be a random point. All right, so we click the parabola and we do our vertex. Don't go over, but go up 8. It's going to flip upside down, so that's the highest point on it, or a absolute maximum. Okay, and then my other point, I wanted to do 1, 7. Sorry, I got it off of there. So 1, 7. All right, and it's going to only give me 25%, but we'll do it anyway. So 0.25, I only did 1/4 of them, so that's good. That graph is okay. All right, so I'm going to skip those other graphs because it seems like we're just doing the same thing over and over. But I wanted you to see a negative, and I wanted you to see it when it was just x squared. So this one up here, x squared minus 8, that vertex is going to be 0, negative 8. So, all right, ready for the next one. So we're going to go to question 3. Right, and they're giving us a function, f of x equals negative 2, x plus 8 squared minus 2. All right, it says find the vertex and the y-intercept, and it asks us about the x-intercept. Right, you can easily find your vertex here, right, because you're in the proper form. Also, you know that this one turns upside down because of the negative. So our vertex we'll do first, right? This is plus in here, so it's going to be negative 8, and it will be a negative 2. That's the vertex. To get your, it's asking us for y-intercept. The y-intercept is kind of big on here. I'm going to hang on to that and put this into a calculator, right? So I know the vertex, and I know it's going to open down. Right, but they're asking me specific points, not just to graph it. If they did, I could pick a random point and put in here. Since plugging in 0 gives me too big. 8 squared is 64. That's going to be too big. So I wanted to pull this up on your calculator. And let me make sure. Oh, I was using my calculator, not this one. So this one should have nothing in it. So negative 2, parentheses, x plus, and I need to make sure that whole thing is showing for my video. X plus 8, close parentheses, to the second power, minus 2. And we'll go ahead and graph it. All right. This gives us some information right here. If we look at the third question says determine the x-intercepts. Right. So this graph opens down. It's never going to come back up here and cross this x-axis. So there are no x-intercepts. The way to solve for x-intercepts algebraically is set y equal to 0. You would get complex answers. So you would get answers with i's, okay, because it doesn't cross. So this one is going to be D and E. Does not cross. Whoops. Okay, that's the answer. The y-intercept, let's look at it on our calculator a minute. To find the y-intercept, you plug 0 into x. The easy way to do that on the calculator is to do second calc. You've already got it plugged in, and value, and put in 0 for x. Whoops, value. Choice 1, I got to click that first. And I'm going to put 0 in for x, and that will tell me the y that goes with it. So, see, it's way off our graph, negative 130, but we don't have to have a graph here. So, 0, negative 130 is the y-intercept, right? And that is by definition because I set x equal to 0. All right, and vertex we found negative 8, negative 2, just from the form. All right, so our calculator gave us a lot of information there. We didn't have to find this one at all. This one we could find by plugging 0 into x. So, and that is second calc value and then set x equal to 0 to do this piece right here. Okay. And you could also do it by hand if you wanted, but you really want to learn to use your calculator. All right, so this one's going to be the same type of question. Gives us a function. And first we'll pick the vertex. And this is plus, so it's going to be negative 6 and 18. This one is going to open down because this is negative. You don't have to know that for now, but that helps you with your parabola. You can get a mental picture. Looks just like that. And so this is our vertex. Right, y-intercept is when we plug 0 into x, and that's going to be pretty big again, so I might wait and do that for my calculator. And x-intercepts, I will do that for my calculator. X-intercept is a pain to do by hand because you have to do 0 and then you're solving a quadratic. Okay. All right, so let's pull the calculator back up. We'll clear y equals, clear this one out. So we have negative 2 parentheses x plus 6 close to the second power plus 18. And we're going to say graph. Right, and this one you need a better window. We know the vertex is at negative 6, 18. But your y would need to go higher. So that's something telling you information about using your calculator. We already have it, so we're okay there. Oh, we could make it better. Let's go ahead and take these x-intercepts off first, though. This one looks to me, and you have to check them. You can't just visually say that's what it is because it might be a fraction instead. So my x-intercepts, right? It looks to me like negative 3. And it looks like 4, 5, 6, 7, 8, 9. And negative 9. Right? I'm going to verify that by doing second calc value. Second calc value. Actually, that's not going to verify those. That's going to do something else. All right. If I do that, second calc value, and if I put 0 into x, what's it going to tell me? Y-intercept, Mrs. H. So, we'll go back to those others in a minute. Y-intercept is 0, negative 54. All right, so I can enter that answer here. That's a calculator. All right, this one. All right, I have a good guess at what they are, but I want to verify. Right, and I was doing the right thing. So when I put in x equals negative 3, because that was my guess, so second calc value, enter negative 3. That's your guess. And what you want is for the y-intercept on it, or the y value on it, to be 0. And that means it's not on a fraction. That's exactly where it is. So this one we confirmed. Confirm these with second calc value. They looked like they would be integer values. And this one was. All right, and then we do the same thing for the negative 9. So second calc value, choice number 1, and we'll try the negative 9, enter, and it does give us y equals 0, so that is good. Right, so those are our intercepts, and they want it as ordered pairs, so the answer will be negative 3, 0, and negative 9, 0, and you'll have a comma between those when you enter them. All right. And I didn't bother changing your window. You could have to see the vertex, but we were able to pick it off, so there's no reason to. And also the y-intercept we could find without actually seeing it on the graph. All right, 5 is giving us a different form.
Miss H, I have a quick question.
Yes.
When I hit the second calc value on my calculator, how can I switch it from X to Y?
You can't.
Oh, okay.
You have to plug in X.
Okay, but what about for if the x-intercept of it?
The x-intercepts are the ones that you're able to check.
Okay, but the y's
you
are the
can't
ones
plug y equals 0 in. I'm sorry. You can only plug into the x because your function, it's required to set up in function notation, which is y equals. So you're not allowed to choose for y, but I will show you one in a minute where we have to find those x-intercepts a different way.
Okay.
Thank you. Where they're not like an integer, because we did it by looking at it on that one. We'll find one that's not an integer, and we'll move to find them.
Okay.
So we sure will. All right, so we have a different form here. It doesn't give you as much information right off the bat. It is a parabola because it's a quadratic. Also, you know which way it opens. The coefficient of the square term is positive 1. So this one is going to open up. And this kind, you have a formula for your vertex. Your formula, and you need to memorize this. It is, for the x-coordinate, it is negative b over 2a. And then you plug that in to get the y. And that will give your vertex. So, and we're in standard form. So my a is 1, my b is negative 6, and I don't need c for the vertex. All right, so I already have a negative 6, so this will be a positive 6 over 2 times 1, which will give me 3. And then I want to find f of 3. That will give me the y coordinate. So you can do this by hand, or you can put it in your calculator. And it would calculate this for you. If it's really nasty, I will plug it in the calculator, even if I don't need the picture, just to make it do that part. Right? We can do this one by hand, I think. This is a 9. 3 squared is 9 minus 18 plus 25. This is a negative 9 plus 25. And 25 minus 9, 15 minus 9. So this is 16. All right, so 316 is the vertex. All right, from this form, it's very easy to do the y-intercept by hand. You plug 0 into x. Well, you're going to plug it here into x squared, and you're going to plug it here. It's going to wipe those out. This last piece from this form is going to give your y-intercept. So it is 0, 25. All right? And you can go through and plug those, but that will work every time. The 0 is going to wipe those two out and just give you that. So your y-intercept is easy to pick off without too much work. All right, our x-intercepts, we will go through the calculator route and see how it looks. So to clear that one out, and we have x squared minus 6x plus 25, and I'll say graph, and I'm not going to see part of it because my vertex is at 316. My y-intercept is at 0, 25. Wow, I'm not seeing any of it. This is a good place to change a window. All right, so it looks like that y needs to be a whole lot higher. Let's change the y value. So window, we'll leave the x alone. And the y minimum, we'll leave. And let's change this to 40. Actually, we don't have to go that. We'll go 30. And we'll change the y scale to 2. Right, and now we'll just have to tell it graph. All right. So there's a picture. And we did expect it to turn up. Here's your y-intercept. Remember, we changed that scale. So each tick mark is not 1. What does this picture tell you about x-intercepts? There are none. It's not going to cross. This is the lowest point. Your vertex is the lowest point on the graph. It's not going to turn around and come down here and cross this. So there are no x-intercepts. If we solve this by hand, we would get i's for the solution. So this one is also going to be D and E. And we'll get another one where I will actually find them on there for you. On the calculator. All right. Then I went to 7. And here's our function. And the first thing they ask is, does this open up or down? Right? This is a positive 1 in front, so it's going to open up. Right? And they want the vertex. So vertex is going to be the formula. Negative b over 2a and then plug that in. All right, so my A is 1, my B is 4. So I have negative 4 over 2 times 1 is negative 2. And then I want f of negative 2 equals negative 2 squared plus 4 times negative 2 minus 3, which is 4 minus 8 minus 3. So negative 4 minus 3 is a negative 7. All right. So my vertex is negative 2, negative 7. All right. And since it opens up, this vertex is an absolute minimum. So that's going to be very important for us. The vertex is real important. All right. So we get a minimum on this one. And they want to know y-intercept. Plug your zeros in. It's negative 3. Easy to do from the equation. And they want to know about x-intercepts. So we'll go to the calculator for that. Axis of symmetry, we could answer that one easily from here. Our axis of symmetry is x equals negative 2. The x-coordinate of your vertex, and this is an equation, it is this line that it flips over through the x-coordinate of the vertex. So we didn't get x-intercepts yet. And if we're going to graph them on here, we only need 1 point and the vertex. We have enough. It's going to flip across that. But we will go to the calculator to get those x-intercepts that it asks for. So we'll do that now. And then we'll come back and do it by hand. So y equals, we'll clear that out, x to the second plus 4x minus 3. And, well, that's a fairly good picture. Let me see what my window actually is. I'm always bothered when the scale is not 1. I'm going to change it. I'm going to do zoom standard, and that will put it back to my normal 10, 10, and 1. All right, so x-intercepts here. That's what we were pulling it up. And you can see it opens up. Here is your vertex, negative 2, negative 7. Y-intercept, you can see. It's not real clear, but you could do second calc value and set x equal to 0. That would give your y-intercept. X-intercepts. Now, just looking at this, that is a little bit to the left of 1. So it's going to be some kind of fraction value, right? And it might be an irrational number, not just a fraction, but maybe a decimal that goes on and on and on. And so we're going to find those on the calculator a different way. So because we don't have a good guess to plug in. Before, we had an integer value and we did second calc value and verified. So what we have to do here, because it's not on an integer, and this one is not either, we will do second calc. And these are called zeros. So your x-intercepts are called zeros. That's another term for them. So we will choose choice number 2. Whoops, I have to do it through the menu. All right. And I want to do the other one first. So I need to move my cursor to the left. All right. I'm clearly to the left of this x-intercept. So I'll click enter. Right, now I need to move it to the right of that intercept. Right, so I'm going to move it with my right button on my calculator. I'm clearly to the right of it, and now I have to click it one more time when it says guess. All right, and this will give me the intercept. My y here is 0. So I did second calc value. I chose 0, and then you do left bound, right bound guess to get on there. All right, and my value is negative 4.645751 and 0. So there might have been a fraction that worked nicely. It didn't go on forever. Let's go to the other one. All right, so your steps are the same. Second calc, 0. Right, and I need to move it over here to left bound. You can also type in a left bound. So it's asking me left bound, but I need to be closer to it. I could type in 0 right here because I know it's past that. Right, now it asks me a right bound. See, it moved it to it. Right, now a right bound, I could type it in or I can move the cursor. If I want to move the cursor, I just have to click that right arrow button on my calculator and get past it. So now I'm to the right of it. Click enter, or I could have entered a number and enter one more time. So you're doing enter 3 times. All right, and there is my other one. So it is point. Okay, today, guys. Sorry, talking to this thing. All right, 0.645751310. All right, and we will go back and look in the directions and see if they told us to round. So this is how you find the x-intercepts when they're not on integer values, where you can make a guess and do second calc value. All right, so we're just going to go back up here and see. So they didn't say anything about that. Let's see what happens when I enter this. Okay, so it's a bunch of those. So we're good. Okay. Ours just didn't carry out that far. So I would say these are irrational because they went so far. When we're solving, if it's going to be irrational in our equation, it would have a radical symbol. Right? So if we solve the quadratic with the quadratic formula, we would get a radical symbol when it's irrational. All right, we did all of that one. So, oh, I didn't answer it all. All right, we were going to draw the graph. So drawing this graph, click my tool, click my vertex, -2, -7. You need one more point, but you have the y-intercept, 0, -3, and that is enough for your graph. Right, domain and range you can take easily from your graph. Remember, domain of a parabola is -infinity to infinity if it's a function, so it opens up or down. So this will be -infinity to infinity. Range. Looking here, so you're going to your vertex. That'll move in a minute and it'll be all gone. Okay, for your range, your lowest point is -7 and it goes to infinity. Remember, you're touching the -7. So it's going to look like that. So I took these from the graph. And I didn't answer many of those. It's going to count a whole bunch of stuff wrong. But we can submit to see if the graph was right. So the graph was good. All right. Let's see what my time is like. I put that we could skip this one, so we'll skip it and go to 12. All right, this one is giving us a function. It says determine without graphing whether the function has an absolute minimum or an absolute maximum. All you need to know is does it turn upside down or right side up? Your a is 1, so that's positive. A is greater than 0, so it's going to open up. And that means you will have a minimum. And so we determined it has an absolute minimum. And they want to know what that is. That's going to occur at the vertex. So you need the vertex, which is negative b over 2a. You're in this form. So negative b over 2a. And then f of that. All right, so negative 12 over 2 times 1, which gives us negative 12 over 2 is negative 6. And then we want f of negative 6 is a negative 6 squared plus 12 times negative 6 plus 27. So we can do it by hand, or we can put it in the calculator, even though they said not to graph. Right, this I believe is minus 72 plus 27. We'll just do the math in the calculator. So 36 minus 72 plus 27, enter. So this is a negative 9. If we were putting it in the calculator just to do the math, we would type this in, y equals, and then we would do second calc value and say x equals negative 6. That would give us negative 9. So that is how to do the math on your calculator if this was really worse than it was. Okay. But we'll skip that step because it wasn't horrible. All right. Now, we have the vertex, right? So we have to know what the vertex means. The x-coordinate is where the minimum occurs. The value of it is the y-coordinate. So you have to watch these. Right, so this function has a absolute minimum of, this is the value. So this is going to be negative 9. And it occurs at x equals negative 6. Right, your domain is going to be negative infinity to infinity. All right, now your range without the graph, which is what they wanted us to do. All we have to know is how it opens and the vertex. All right, we know it opens this way, so this is the lowest point of the graph, and it goes from there to infinity. We need the y-coordinate of the vertex, so for our range, it will start at -9, and it will go to infinity. So you don't really have to have the picture. You have to have the vertex. All right, so we got the ones right that I answered. That's a good thing. Okay. From here, I went to 15. This one's just asking it a little bit different. It's making sure that you understand what all these things mean. It's giving you a general function. It's not giving you any numbers. And these are the characteristics. It has an absolute minimum. So that is the lowest point. So it's going to open this way of 26. So that's the value. It occurs at -1. So -126 is the vertex. Right? Because this is giving you the minimum. It occurs here. This is the value. So you're figuring just that out. And then your domain is going to be -infinity to infinity for all your parabolas that are functions, which means that they open up or down. Your range, all you need is this vertex. So we had a minimum. This is the lowest point. That's where it's going to start, and it's going to go to infinity. So it's going to start at 26 to infinity. There you go. Right. I'll just say a word about this one, but I'm going to not write it. Okay. This is just wording it different for you. If A is greater than 0, A is positive. That means it opens up. Okay, and that would make this a minimum. So you have to be able to translate back and forth there and see what you need to know. This means it opens up, A greater than 0. This would be a minimum. So you're going to use that 14 to infinity. There we have it without writing. Okay. And anybody that just looks at the notes, I'm sorry, you missed it. Okay, I wanted to get at least a word problem done. It takes longer to do the word problems. I guess you guys have found that out. I did put 2 in your list of problems. One of them you have to run it forward, but I also put an example of it. Another one, it's numbered 19, but I actually think it's 20 when you look at them. And sometimes I change how many questions are in there, or I did when I first started, so it might be a different number, but you'll find it. All right, so we'll try this one and see if we can get through it. And we're going to depend heavily on our calculator. The last 2, I don't believe you can do on your calculator. I think if you try them, it gets you numbers too high. But this one we can. And this is a common type of word problem. Anything that gets a parabolic pathway. So rockets shooting something up, balls being thrown off of a building, that kind of thing. All right, so here is our function. So a person is standing close to the edge on top of a 40-foot building and throws a ball vertically. All right, so we will just draw a little picture. So a person is standing on this building, and it is 40 foot up. He's standing here, he's throwing the ball, and it's going to come back down. All right, and it's going to hit the ground. This is where he's throwing it from. This is our model. All right. And it's asking us, after how many seconds does the ball reach its maximum height? Right? Its maximum height is going to be at the vertex. All right. So we want to know about that point, right? The x-coordinate of that vertex is how long it takes to get there, right? Because yes, how long it takes to get there. This will be the maximum height. This will be how long it takes to get there. So we need to know the vertex to answer after how many seconds does it take to reach the maximum height. This gets us to the x-coordinate of the vertex, this piece. So this first question is x-coordinate of the vertex. That's question number 1. Number 2, the maximum height. Y-coordinate of the vertex. Right? How many seconds does it take until it hits the ground? Right here is where it's going to hit the ground. And so that is your x-intercept. So those are the things that you need to find, but you had to be able to interpret that. Right? And your y-intercept, it doesn't ask it, but it is actually here the 40, because that's where they're throwing the ball from. They're 40 feet up from the top of that building. So that is your y-intercept on your graph, but they don't ask that. So we're going to go to the calculator to help us find these, and we'll have to play with the probably with the window. All right. This one does open down, and we could find this by hand also. Negative 72 over 2 times negative 16. All right. So we could find those by hand. And yes, we could find them by hand, but we're going to find them on here. All right, so negative 16, and we'll just use this plain function button. It doesn't matter if it's x or t. So x to the second plus 72x plus 40, and we will say graph. All right, and see, I didn't get a very good graph. So I would like to have a better graph, and so I'm going to change my scale. I would like to see the vertex, and I am nowhere near the vertex. Now the other thing I'm going to need that x-intercept. So I can kind of see that. I wonder if I have a different scale in here. Let's see what my window is. No, I'm good there. All right, so let's go ahead and look at this answer for this y-intercept for a second. All right, so this scale is 1, 1, 2, 3, 4, a little bit less than 4. All right, so a little bit less than 4 seconds. So my scale is okay on the x. Let's change the y, and when you have no idea from your picture how high it's going to go, you can do zoom fit. So it's at the bottom. And, all right, so I don't like their picture at all, but I want to see how high I had to go. So now I'm going to look at their window. All right, and so their window, the max is what I wanted on it, 120. So I am going to change my window. I'm okay with those x's. I'm going to change my window. So their max was 120. We don't need that minimum at all because we don't need to go down that far. So let's go back in window. This just gave us an idea how high it needs to go. All right, so it did change mine when I did that. All right, so this one, I'm just going to leave this at -10. Whoops, it's not going to like that at all. -10. And I'm going to make this one, let's make this one 200. And let's change the scale. We're only changing the Y scale. Let's see if we change this to 10. Graph. All right, that is a pretty good graph. Okay, and so now we can get the vertex off of there. We're not able to do it just by looking, so we want to find the max. So we're going to do second calc maximum, and you do left bound, right bound, and guess again. All right, so we did second calc max. All right, and a left bound, I would move it a little bit closer than that. That's good enough. And click enter. Now I want to get to the right of that. Click enter. And click enter one more time. So I have 2.24 and I have a bunch of 9s. I'm going to round that up to 2.25 because that could be round off in the calculator when you get all that. So this from our calculator, the x coordinate of the vertex is 2.25. That's rounded. The y coordinate, which gives us the maximum height, is 121. So we got both of those answers from that one thing, which was second calc max. All right. And now we want the x-intercept. So let's get this off of here. Probably should have found it from the first graph. It's right here. So we're going to move to it. Right in the calculator, this is going to be second calc 0. So it'll be choice number 2. Second calc, choice number 2. All right. And that's not where I want. I want way down here. Oops. And I have to make sure I didn't go past the y-axis because I don't want to get on the other side of it for the left bound. Okay. All right. So I'm above it. These are in the way. All right. And then I want a right bound. So I'm going to keep moving on it until it gets down in the negative. And visually, we looked at it and said it's a little bit less than 5, so I'm probably good for a right bound here. And then I will say guess. All right, and so I have 5, and this is 1 times 10 to the negative 11. This is scientific notation, which is super, super, super tiny, which means 0. So that is very close with round off error. So we're going to say 5 for this x-intercept. All right, this was so tiny. All right, let's look at their answers. So 2.25, 121, and 5. All right. I had requests for more word problems. I'm sorry I didn't get to more. I did look in this one and video 2 I would recommend for question 18. It is not one of our faculty, but that guy is excellent and it's a very similar problem on it. So for 18, I would recommend video 2. He's very good. And his calculator even looks the same. I'll just pull it up real fast. Okay. Very similar to what we had. And his explanations are good.
We want to solve.
Okay, I don't want to listen to you though. This one, you can listen to Miss Allen. She is very good on this one, probably better than I would explain it. And I can come back to it tomorrow or the next time if you still have trouble. And this one, actually, I think I had the video for, but I called it number 19. But it's actually 20 with that pin. All right, so I will stop there and I will get your test finished. That will be my first priority. All right. You guys have an awesome day.